Okay, so chapter 13, and it was over the states of matter, and this just kind of got us into the swing of things, teaching us about the nature of the gases, the liquids, and the solids. And so, starting off in section 1, we learned about the nature of gases, and we discovered some general characteristics of gases that help explain how odors travel through the air. So that was kind of our main topic there that we learned about. So according to the kinetic theory, all matter consists of tiny particles that are in constant motion. The particles in a gas are considered to be small, hard spheres with an insignificant volume, which these are kind of self-explanatory. It's just the little things that we don't think about. The motion of the particles in a gas is rapid, constant, and random. All collisions between particles in a gas are perfectly elastic. Gas pressure is the result of simultaneous collisions of billions of rapidly moving particles in a gas with an object, which that one is so true because the more something is colliding with each other, the more faster it'll start moving. And the Kelvin temperature of a substance is directly proportional to the average kinetic energy of particles of the substance, which we know of this as being true. And after doing some of those labs and stuff, we definitely found all these to be true. And it just helps us explain the average kinetic energies and how it relates to the Kelvin temperature and how to better use that. So we move on to chapter 13, section 2, which is the nature of liquids. So moving from gases to liquids, we learned that the properties of certain liquids vary, and we identified those. So the interplay between the disruptive motions of particles in a liquid and the attractions among the particles determines the physical properties of these liquids. And then during evaporation, only the molecules with a certain minimum kinetic energy can escape from the surface. And we discovered some general characteristics of these and just how everything goes. So here below is kind of like a little visual to help map it out. So the evaporation turns into a liquid, then the liquid goes to condensation into a vapor, and that's just kind of a big circle that keeps going on, just like a cycle would. And so we know that when liquid is heated to a temperature at which particles throughout the liquid have enough kinetic energy to vaporize, the liquid begins to boil, which is kind of like how the cycle shows. And then it also shows that in a system at constant vapor pressure, a dynamic equilibrium exists between the vapor and the liquid, which is shown, and the system is in equilibrium because the rate of evaporation of liquid equals the rate of condensation of this vapor. So that kind of sums up section 2. Moving on to section 3, we have the nature of solids. In this, we learned how the arrangement of particles in solids determines some general properties of different solids. And so the properties of solids reflect the orderly arrangement of their particles and the fixed location of these particles. And then the shape of a crystal reflects the arrangement of the particles within the solid. So just like the last section, it showed the model for solids and the cycle that it goes in, from melting to solid to freezing to liquid, and just in a continual cycle for that. Moving on to the last section in this chapter, we have the changes of state. And this one we learned about sublimation, the different kind of phase diagrams that we'll see, and just in depth about those. And so we learned that the conditions it takes to control these certain states of the substances that occur. So sublimation occurs in solids with vapor pressure that exceed atmospheric pressure or at room temperature. So that is why that happens. And the conditions of pressure and temperature at which two phases exist in equilibrium are indicated on a phase diagram by a line separating the phases. So those are two major factors that we need to learn in this section, and overall this section was just talking about certain natures of liquids, gases, and solids.